Okay, so something to tell you. Lecture notes, again, as far as the BJC is concerned, lecture notes are there for completeness. We may not be explaining every single thing in lecture notes. So we'll be only highlighting the relevant and more important details. The rest is something like a textbook you can just read on your own. So syllabus includes all these blah blah blah, you can read on your own. Okay, so notations, firstly, today's lesson is going to be quite dry because we are just running through some of the preliminary stuff. The monster will start next lecture. What I need you to do, please pay particular attention to the notations by which how vectors are represented on your printed test paper. When you receive your question paper, sometimes vectors are denoted in bold print. Okay, some are sometimes denoted in bold print, sometimes it's denoted in tilde form. That means with a small letter with a little worm at the bottom. Okay, I call it the little worm at the bottom. Sometimes vectors are represented by capital letters with an arrowhead on top. Okay, so 1, 2, 3. These are the three typical forms or three representations by which you can represent vectors on your question paper. So sometimes Cambridge like to do part 1, sometimes they do part 3. It doesn't really matter. Understand how it looks like. Okay? Okay, and then please get used to this term. You see these two strokes in between your small letter with tilde. Okay, two strokes in between your vectors. Be careful. Please write down. Sometimes it may mean magnitude. Sometimes it may mean modulus. So it all depends on how the question is being said, and then you need to interpret accordingly. So if nothing really mentioned, and I just write like that, okay, a small letter with a little worm followed by two strokes, it will usually mean the magnitude of a vector. What's magnitude? In simple English, length. Okay, the length of your vector. Okay, so this is just the starting to get everything warm up. Then, important thing, when I talk about vectors being equal, when I say vector A is equal to vector B, it implies two things. Okay, please take note, it implies two things. Meaning they have the same direction, that's one. They also have the same length. So, if vector A equals to vector B, equal magnitude, equal direction. Okay? So along the way, please highlight the important thing. So this one, highlight. Have the same magnitude, same direction. Okay? Okay, then there's another thing called zero vector. So as of now, you may actually don't understand what the hell is a zero vector. To you, zero is zero, right? But a zero vector have a little worm at the bottom. Okay, you see this little worm at the bottom of your zero. Okay, right now you may not be able to understand, but what it means is if I tell you a zero vector, it means like that. 0, 0, 0. Okay, you just write down first. Later on, as I move along, this thing will come back into play again. Okay, so take note when we say zero vector, it's zero, no direction, no length, no magnitude. Okay, so far so good. Then, if I say that I have a vector that is A, I have another vector that is negative A. Can anyone tell me what's the difference? Different direction only. So if A is to your left, that means minus A is to your right. But they share the same length. Okay, easy so far? Next definition, unit vector. Unit vector means a vector of length 1. That's why it's called unit vector. It has a length of 1 in a certain direction. So take note how to represent your unit vector. This one please highlight again. We represent unit vector by A, small letter, little worm at the bottom, and a hat on top. This is how your question paper will represent your unit vector. Okay? So in simple terms or equation form, your unit vector is equivalent to vector A divided by its length. Can you understand how this thing comes about? Can? So next one, vectors addition. Probably you have learned this before in your secondary school. I know some schools do vectors, some secondary schools don't do vectors. So for those who have not done vectors, take note, reminder again, a vector comprises of a length, comprises of a direction. So follow with me. If I say this is vector V, this is vector W, what is vector V plus W? So think of it as how you walk. Start point, walk to here, N. And then I'm going to continue. And then you walk up in a certain direction. V plus W is your so-called resultant. Is this concept familiar to you? Familiar? Secondary school? Any secondary school never teach you vectors, simple vectors like this? Oh, okay, huh? We can go fast. So if you can do vector addition, how to do vector subtraction? Minus means opposite direction, right? But equal length. So V minus W. So if this is V, this is W. So instead of going up, W is coming down. So V minus W, this is your resultant. Can you understand? Anybody lost so far? So far so good? Easy, huh? So you'll be thinking, right, how can this topic be terrible? Yeah, as I said, today is very dry, very easy. Okay, scalar multiplication. So, simple stuff. If this is vector V, what is 2V? Double the length. And what is minus 2.5V? 2.5 times the length, but change direction. So far so good? Easy? Can, so if it's easy, we move fast. Okay, so this is the first set of properties that you have. Okay, this one please listen carefully. As far as your vectors is concerned, you have 3 separate sets of properties. This is the first set. You're going to get another set of properties in your chapter 2. You're going to get another set of properties in your chapter 3. So, can you please asterisk the properties? Why so? Because in your A-level question, typically, as I said, over the past 10 years or more, there will be 2 questions coming out from vectors. One question got number. The other question got no number one. That means ABCD, unknowns. So when you're dealing with vectors question with unknowns, you need to be very proficient in your properties. Okay, so right now, properties, die must be super proficient. Okay, first property, can understand on your own. If I put a lambda in front of SA plus TB, it becomes lambda SA plus lambda TB. This is actually your distributive law. I know some of you don't like this ABCD rubbish, so I give you like that. 2 times of 3A plus 6B. Equivalent to 6A plus 12B. Okay? So nothing fantastic, just your distributive law that you have always been proficient with. Okay? Next one, second property. If I tell you that vector A is parallel to B, take note, I say parallel. Parallel will then imply A is equals to K times of B. Can visualize why is this true? Parallel, does it imply equal length? No, right? So they can be parallel, but they can have different length, right? So that's the purpose of the K. That means I can say A is equals to 3B. Make sense? That means they are parallel. Okay? And take note, right now it may not be of particular interest, but can you please highlight this non-zero vectors? Okay? I need them to be non-zero. At this point in time, it again may not be critical to you, but take note first. These are the little things that may be very important subsequently. Okay, number 3. Can you please asterisk? Okay, this one is one of the most important properties. Okay, and one of the terms I need to be very clear with you is collinear. What is the meaning of collinear? Is that the points lie in the same straight line. So pictorially, you see in the diagram below, you see ABC. ABC lies on the same line. So this one, very often tested in the exams, and I believe your CT1 confirm will test you this one because we learn about this to test. Okay, so how do I prove that 3 points are collinear? Look at the first box. If I say that AB, yeah, take note of the notation. Now I use capital letter. Capital letter with the arrowhead. What does it mean? Is capital letter AB the same as capital letter BA? Same or not? Different. Okay, please remember vectors got direction. So when I say vector AB, that means A to B. When I say vector BA, it's B to A. Okay? So I say that vector AB is equals to K times of vector BC. What does that prove? If I say vector AB is equal to K times of vector BC, what does that prove? They are parallel. Okay? So this one proves that they are parallel. Okay? So why is this special point B? Why must I say that B is a common point? If A and B is AB is parallel to BC, and then at the same time B is a common point, is it conclusive that they are on the same straight line? Yeah. Okay. So many students, okay, year in year out, they just give me this. Okay, this is not conclusive. The rule of thumb is if it's a proof question in the exams, please treat the markers as total idiots. Okay? Because many students tell me that AB equals to KBC. B is there already, so obvious. What's there to say? Okay, rule of thumb, treat the markers as idiots. So specifically mention B is common. Okay? If you don't like this first box, can I use the second box? Think now. I say that AC is T times of AB. And then this time around I say A is common. Is it sufficient? Is it conclusive that A, B, C are collinear? Okay? So you can use this. Is this all? Can I use any other vectors instead? How about BA and CA? Can? I can use anything. Okay, so the choice is yours. As long as you can prove to me that two vectors are parallel, and then there's somehow a common point in between, and please specifically mention the common point, you can prove the points are being collinear. So what's good? Can? Okay, so now ready for the big game. Secondary school, most of the time I believe your teachers would have taught you this what we call column vector representation. And this is the column vector representation numbers. Okay, in vectors. This is alphabet. This one is numbers. So typically how we represent a vector is in terms of column vector. Simple thing. Number on top is your x coordinate. Number at the bottom is your y coordinate. Okay? X coordinate, y coordinate. Then, if I ask you for the length of that vector, it's basically just Pythagoras theorem. Very, very simple. It is two-dimensional. What happens when it's three-dimensional? Okay, so this is when this topic becomes very abstract for some of you guys. Your questions surely will be three-dimensional, not two-dimensional. 2D, flat on the ground. 3D, I have an additional dimension upstairs. So if I say that this is your x direction, that is your y direction, that this upstairs is your z direction. Okay? So your x, y, z. These are the three so-called x's for your three-dimensional vectors. So nothing fantastic. It is just, again, x, y, z coordinates. If I ask you for the length of the vector, it's actually, again, just like your Pythagoras theorem, is the square root of the sum of squares. Okay? It's square root of a squared plus b squared plus c squared. So I give you some numerical example. So if I tell you OP is equals to 1, 2, 3, what does that mean? In layman or in real terms, yeah, I say this is x direction, this is the y direction, upstairs is the z direction. 1, 2, 3 means 1 unit to the right, up to your left, then 2 units forward, and then 3 units upward. So where is that vector? It's somewhere here. Can visualize what's happening? Can visualize? So if I ask you for the length, so what does the length mean? What does the magnitude mean? The magnitude, okay, now it's more important now. In simple English is the distance of that point from the origin. So, mari 1 unit here, 2 units here, 3 units up. So this is where the vector is. So where is the distance, or what is the distance of this vector from the origin? The origin was here, right? So I want this length. Can follow? Okay, you see me doing all these things, you'll be doing that in the exams. So when you're doing the questions, right, sometimes you see students in the lecture hall, exam hall. They'll do that, okay? So, do not laugh, okay? This is the way to survive. You must understand. I can show you fanciful computer graphics, but when you're doing your exam papers or exam in the exam hall, you don't have computer to help you, no? So the only way to visualize is to use the table, use your pen, use your eraser, use the paper. So you'll be thinking, moving things around with your hands. Okay? So all these things will be happening. Okay, so how does this thing come about? Actually, it's just a Pythagoras theorem. I will not go through with the proof. The proof you can self-read, it's just down there. Okay? Okay. So there's one thing I never mentioned just now. I tell you the x coordinate, y coordinate, z direction, x, y, z. Okay? So vectors in your in so-called convention, usually we don't say x, y, and z axis. Okay, the more conventional representation will be the I, J, K direction. So x is your so-called I direction, your j is your y direction, your k is your z direction. Okay, so sometimes, so 1, 2, 3. How I can represent 1, 2, 3? This is column vector form. So sometimes some idiot setter will set exam like that. I plus 2j plus 3k. Okay, I tell you that OP is equal to I plus 2j plus 3k. So it means that they are equivalent. 1, 2, 3. X direction, Y direction, Z direction. So far so good. Okay, so this is the thing about vectors. Many different forms of representation. Okay, so again, if you ask me why must I have so many things, it's for coding purposes. To code into the computer, sometimes it's easy to code column vector. Sometimes it's easy to code 1 to ijk. Okay, so this topic, okay, the actual what you call that? Real life application of this topic is a lot of computer graphics. Is on GPS, on codings. Okay, how you do your 3D imagery, how you do your cartoon drawing in the computer. This one. Okay. Okay. So next thing, if I ask you to do vectors addition now, I teach you numerically, you can handle. Vector v plus vector w, this is the resultant. So what if I give you numbers? Okay, all these ABC stupid. Okay, I give you like that. 1, 2, 3 plus 4, 1, 1. Are you able to give me the answer? All you need to do is add horizontally across. So this becomes 5, 3, 4. Okay. Anybody who knows what's happening? Comfortable? So if you can do addition, you can do subtraction. Okay? So this is just one example. Example 1, vector v plus vector w. You need to fill in the blanks? Or fill in the blanks already? Okay, everything done for you. Nothing much for you to copy. Comfortable? I'll just keep. Okay? So just now, I told you that if I give you 3, 1, 2, 3 is equivalent to 3, 6, 9. This is your scalar multiplication of your vectors. It's one of your key properties, please remember. So same thing, 3v is 3 times of your 1, 2, 3 minus v, just add a minus sign, everything settled. So far so good, easy? And you a bit, I know, very dry. Okay, so if I say that vectors are equal, okay, v1, what it means is if you compare horizontally, they are all equal. Simple stuff again. Magnitude, okay, this is how you represent the magnitude square of the sum of squares. Okay? Okay, so this one. This is when it becomes tricky for you. I told you, you're going to get a question that doesn't have numbers. So, if I give you lambda v, this one, take note. Lambda is subsumed in your magnitude sign, magnitude symbol. The lambda can come out because it's a number. Okay? Then similarly, if I tell you negative v, the negative can come out. Okay, this one will be negative 1. So what is the, let's use layman English to help you. This magnitude of minus 1 is magnitude of v. Magnitude means length, right? What's the length of minus 1? Length of minus 1? 1. So the sign just disappeared. So this is why sometimes students confuse magnitude with modulus. Okay? Okay, come. This one, try on your own. Try. Simple. You are given vector v is 6 minus 3, 2. Find the magnitude of v. So all you need to do is activate the square roots of the sum of squares. Answer 7. Can. Don't copy out. This one just try. Okay, thereafter, if you can survive this, you are supposed to hence find the other magnitude. Take note, this is a hence question. By now you should be very proficient. What does hence mean? Hence means that you cannot do everything all over again. You cannot tell me, oh, it's a square root of 18 square plus 9 square plus 36 square. I give you 0 straight away. So what does hence means? Hence means I need to make use of my previous answer. So what we will need to see is you taking out the minus 3. Okay, take out the minus 3 from your column vector. Okay, this is your properties understanding. Your number can come out. And after that, minus 3 as well as this column vector, the minus 3 can come out from the magnitude sign. So magnitude of minus 3 is actually 3. The length of minus 3 is 3. So it's just 3 times 7. Okay? Questions so far? Anything not clear? So far so good? Questions? Nothing? Next one, Okay, take down your units vector. Units vector means in your layman English, vector of length 1. Okay, is vector of length 1. And usually at this point, right, students cannot understand anything. So don't worry, I will explain in a short while. Take down first. I'll refer back to your previous example to help you understand. Anna, take down already? Okay, good. Let's look back into this. Okay, this was the question that you did just now, right? Okay, 6 minus 3, 2. What's the magnitude? 7, right? Okay, look at the one I circled in red. 6 minus 3, 2 has magnitude 7. It has length 7, right? So you have one length, one top. Just take 1 7, right? Is your rates and proportion. You understand? 6 minus 3, 2 has length 7. If I want length 1, take 1 7. That's how this formula comes about. Can understand? Can understand? Make use of your proportion to help you. Okay, so some people like to memorize by formula. Usually I would recommend. Understand by logic. Okay, find the length of a vector divided by its magnitude. That will be your unit vector. Okay? So, okay, all these don't need to read now. Okay, so take notes. These are different manipulation of your unit vector. Okay, not to pay too much attention to it. Okay, it's just for your information. Let's proceed on to Example 4. Find for me the unit vector of V. Try on your own now. Okay, try to understand by logic, not by formula. Okay, find for me the length of V divided by its magnitude. That will give you a vector of length 1 in the same direction as V. So far so good? So far so good? Anyone totally confused? Anyone cannot understand? Please raise your hand. Okay or not okay? If you're okay, can you please fast forward to example 5? Okay, that one is more interesting. Okay, you can forget about this 5.1. It's just like a textbook. It's for completeness. Okay, this time around, I want you to find a vector V of magnitude 14 in the direction of 362. So how do I do a question like that? Okay, you can do this question without my help. That means you understood everything on unit vector already. Okay, I want to find a vector magnitude 14, a vector of length 14 in a stipulated direction of 362. So what should you do? Okay, make use of the concept of proportion to help you. Okay, you see two columns in your boxes provided for you. Okay, the one on the right basically teach you the theory behind it. The column on the left basically gives you the space to try and understand what's happening. Okay, so the hint given to you is you need to make use of the concept of proportion. Yeah, for those who actually have no idea what is going on, listen to me now. Okay, I will start off with 362. I want to find the length of 362. Okay, can you find the length of 362? It's as good as finding the magnitude of 362. After I find the magnitude of 362, the magnitude is actually how much? 7, right? If I divide by 7, it will give me length 1, right? So I have the vector in the direction of 362 but of length 1. This is the vector in the direction of 362 length 1. So if I want length 14 times 14, can get? Anybody don't know what I'm doing? Balik. Okay, so I have a 362 down here. Okay, 362. Can I find the length of 362? The length is 7. So 362 has length 7. If I divide by 7, it will give me a vector in the direction of 362, but of length 1. Make sense? So now the question is, I want a vector of magnitude 14 in the 362 direction. So with this answer, times 14. Can follow. Okay, understand from proportion, it is easier to accept. If you memorize formulas, this thing won't form in your head. Anyone see a problem understanding this? Anyone still confused? Anyone still confused? So let me extend the question now. If I want it to be length of 20, how? I want length 20, how? Previous answer times 20. If I want in opposite direction for a length 20, how? Times negative 20. Can? Okay. Okay. Come on. Okay, 5.2 directional cosine. Right now, at this point in time, just take it as this is the formula. There will be a topic, there will be a chapter or section dealing with your directional cosine in chapter 2. So we will deal with directional cosine later on. Okay, so this is the part. Okay, try to understand a bit. Okay, this one can be confusing for some people. Okay, when you actually get a question in the exams, please read question. What does your so-called column vector represent? Okay, I'll give you a very simple example. Like that. Okay, 1, 1, 1. If I just tell you 1, 1, 1, can you give me your interpretation? Is it a point or is it a direction? Based on your understanding so far, 1, 1, 1, what does it represent? A point or a direction? A point. So your interpretation is 1 unit to the x-axis, 1 unit in the y direction, 1 unit upstairs, right? So it will be here. So 1, 1, 1 represents this point, right? Okay? So yes, this is one way to interpret this. If I never say anything, I just tell you, 1, 1, 1. So the interpretation is 1, 1, 1 can be a point. Okay? 1, 1, 1. However, if I tell you like that, OP is equal to 1, 1, 1. What does it mean? Do I still mean a point? OP equals to 1, 1, 1. Or I tell you AP is equal to 1, 1, 1. Okay, so if I represent a vector in this form using capital letter, what it means is that it is the position of P, first one, position of P relative to O. Okay, so OP111 means that the position of P relative to O is a point. If I tell you AP is equal to 111, it's the position of P relative to A. And starting from A to P, this point is 111. Can you understand? However, if I tell you like that, A is 111, small letter now with a little word below, what does it mean? It no longer means a point, it means a direction. Okay, it means this direction, 111. So if you look at what you have in your lecture notes, okay, it will look like that. If I tell you OP equals to 1, 1, like that, okay, that means P relative to O is 1, 1. But if I just draw like that, and I use small letter b and say that it's 1, 1, it means that direction B is 1, 1. B, A, small a. Direction A and direction B both share 1, 1. It's in the same direction, but they need not start from the same point. Can you understand? So this is how come sometimes people prefer to use capital letter. Sometimes I need to use small letter because they mean different things. Can? Okay, so take note. And when I give you a column vector with no further explanation, it can mean a point, or it can mean a direction. But if I accompany it with capital letter or small letter, then it may mean a point or a direction. Okay, so this is one of the more important things that you need to understand as of now, because the real question have not come out yet. Okay, so this one should be very easy. Displacement vector. AB, okay, all these things. AB equals to AO plus OB equals to OB minus OA. Can accept. AB is from A to O and then from O to B. Okay? If I were to swap the direction, I'll swap the direction for this. AO is the same as minus OA. So this becomes OB minus OA. Follow? So this representation, anyone got problem? So let's look at it pictorially. So what is AB? What is AB? Pictorially now. And I say AB is AC plus CD plus BD. Can? Can. Okay, so this is basically what we mean by displacement. Take note of start point and point. Then do not screw up. Can? Start point, start from A. I need to somehow arrive at B. So you can go from A to C, C to D, D to B. Whichever way you want, make sure it's one closed loop. You will be fine. Can? Okay, so basically this is the issue on displacement vector. Still okay? Okay, okay, I need you to do some changes to your lecture notes. Look at the portion highlighted in yellow. Basically what I have done is I have changed your A to O. Okay, I have changed your A to O. Can you please make the amendment? Okay, I think this way is easier for you all to understand. Okay, make the changes. I've changed all your capital A to the letter O. Okay, after you are done changing, can you spend some time reading this example? Okay, many years ago, there was this section called 3D geometry in your H2 in the math syllabus. But the syllabus change have removed this section. But the sad news is, in recent years A-level, they like to test students' ability to visualize 3D stuff like this. Okay, so make the changes here. Some more at the bottom, and the diagram also please change. Diagram, can you please change to down here instead of A? Okay, done your changes. Okay, now I want to run a test on I want you to run a test on yourself. Looking at the diagram, looking at the information provided in the grandmother story up here, are you able to write down the coordinate of OB, or the position vector, column vector of OB, OC and OD? I left it blank for you. Can you check and try? Do you have the ability to write down OB, OC, OD? Okay, purely by reading the story and then understanding the various distances from origin. Are you able to tell me what is OB? A 3D, three-dimensional. OB, OC, OD. Okay, why is this skill so critical is, if you cannot do this, the whole question cannot do anymore. Okay, so this is the thing sometimes students falter in, because there is no specific chapter or specific topic by which we teach 3D geometry. So this is the only chance by which I can test you guys. Do you have the ability to read off OB, OC, OD based on the story as well as the diagram? Okay, because to me it's by observation I write down answer. But to some of you it's a struggle, you know. Try. How many units in the I direction? How many units in the j direction? How many units in the k direction? Try to understand from the story and write down the 3 column vectors. Can or cannot? Who seriously have problem? Okay, so for those who are having problem, let me just roughly run through the theory. Okay, you need to take note of this information here. They tell you OA prime, BB prime, CC prime, DD prime is 2 meters. And then taken, here the point O is taken as the origin, and then you need to tell me this one. OB is 3 meters, BC is 2 meters. So these are the information that will help you to decide what the 3 column vectors are. Okay, so in the exams, usually students will just write column vector. This is not necessary. The IJK can be confusing. So most of the time, students just write column vector. In IJK, it's just for completeness of the lecture notes. Can? Okay, so if you can do this, subsequently, you should be able to do your OA prime, OB prime, OC prime, OD prime. Can? Okay, so the bigger problem will be actually OS and OR. Okay, S and R is here. So why is it so a little bit tougher? Is because it's no longer straight line, right? It's no longer straight line, but you can just measure also two units. 2 units, you can just move on. This one is like hanging in the middle of the air. So how? Well, secondary school skills have to kick in. What kind of secondary school skills? Okay, so before I go into the secondary school skills, take note of this thing. The roof is inclined at an angle of theta to the horizontal, where tangent theta is 3/4. Okay, the roof is inclined at an angle of theta. Tangent theta is 3/4. So your little bit of geometry of trigo have to come in. So this is the cross section of the roof. This is 1 unit, this is 1 unit, this is angle theta. Can you find for me this length? If tangent theta is 3/4, this one is 1 unit, can you give me this? Okay, so via your trigo, you can tell me that SH actually have a length of 3/4. So where actually is your B prime S? It's actually 0, 1, 3/4. And so if you can find what is B prime S, you can find actually what is your OS using your vectors displacement. Is OB prime plus B prime S. Start point O, go to B prime, then to B prime, to S. Okay, if you can find what is OS, you can actually find for me what is OR, because the roof is the same. It's just the opposite side. Okay, so the additional skill required in this question is actually a little bit of geometry, a little bit of trigo to help you. So far so good. So far so good. Okay, go home, spend some time going through this question. We are still at the initial and easy stage. Okay, so try your best. I'll